Okay, we're going to talk about matrix transformation, rotation, reflection, enlargement, and stretching. Later on, we'll talk about images in another separate video. Anyways, this is a multiple part video. So first, we're going to draw the image, and then we're going to show how we can modify, transform images using matrices. So we'll talk about that in just a minute. So, so rotate 90 degrees. So this point right here, counterclockwise. So we're going to go this way, right? So this point here, this is 1, 1, and that's going to transfer over to here at negative 1, 1. This point right here, which is 3, 1, is going to transfer up here to negative 1, 3. And this point right here, which is negative 3, 2, is going to transfer here to negative 2, 3. Uh, 3, 2. Okay. So I think what's important to notice is how the numbers change, and we're going to talk more in detail about that when we start making our transformation matrices. Okay, so reflection on the line y equals x equals 0. So x equals 0 is this line right here. So this is a reflection on the y-axis. Okay, a lot of people messed up on that one during class today. Reflection on the line y equals 0, x equals 0, and this line right here is x equals 0. So if I treat it like a mirror, this point right here is going to be right there. Oh, wait. Did I do this right? I think so. This point right here is going to go right here. That's going to be right there. Okay. So if this point here is 3, 1, this point right here is negative 3, 1. Enlargement. So if this point is 1, 1, the new point is going to, if it's enlarged by a scale factor of 2, this is going to be at 2, 2. This point here is 3, 1. The new point is going to be at 6, 2. And the next one, and this is 3, 2, it's going to be 6, 4. I need a ruler here. So okay. So okay, stretching parallel to the x-axis. So that means this point 1, 1 is going to transform to 2, 1. This point here, 3, 1, is going to transfer to 6, 1. And this point here at 3, 2 is going to transfer to 6, 2. So basically what's happened here is the x value has been multiplied by a scale factor of 2. So the x value has been multiplied by a scale factor of 2. So okay, it's been stretched. Okay, so we're going to talk about how to do this using matrices now. So let me get another handout to help with this. Okay, so what we're going to do right now is we're going to make a reflection. So we need to get our vocabulary figured out first. So this right here is called our transformation matrix. This right here is called our image matrix. And our result will be our result matrix. Okay, so okay, and our image is here. So where did we get these points, these values here? We're going to look at the points on the plane here and get position vectors from each point. So this here is 1, 1. This here is 2, 2. And this here is 3, 1. So from those values, the 1, 1, we've got the 1 and the 1. For the value of C, we've got 2 and the 2. And the value of B, we've got the 3 and the 1. Okay? So that's why we call this our image matrix, because this is the matrix that is used to define our image that we have right here. Okay, so if I multiply my transformation matrix times my image matrix, we're going to get the result matrix, which is where the new reflection is going to be. So if I use my matrix C properties, where I have this row times this column, I'm going to have 1 times 1 plus 0 times 1. And then this spot here is 1 times 2 plus 0 times 2. And then the last one is 1 times 3 plus 0 times 1. Okay. And then so now we've got this row times this column for here. So 0 times 1 plus negative 1 times 1. 0 times 2 plus negative 1 times 2. And finally 0 times 3 and then plus negative 1 times 1. And our result matrix is going to give us 1, 2, 3, and negative 1, negative 2, negative 1. And so my result matrix I'm going to plot over here. And that will be our reflection transformation. So 1, negative 1 is right there. 2, negative 2 is right there. And 3, negative 1 is right there. And so I connect those dots. And it looks like a reflection, doesn't it? Okay. So let the column be the new matrix, be the position So let the columns of the new matrix be the position vectors for the image, which is what we just did. So whenever you see a transformation matrix that looks like this, this will always be a reflection matrix. And the formula packet, you're not going to have to memorize most of these. So the formula packet shows what the transformation matrices are going to be. And we'll talk about this in more detail in a little bit. But we're just getting you used to the idea of what a transformation matrix does. So on the diagram, draw the new triangle after the transformation. So what is the transformation? The transformation is a reflection on the x-axis we could also say on the line y equals 0. Oh gosh, you can't see what I'm writing. Okay. Is the same way. In the same way, use the matrix to find the image of 1, 0, and 0, 1 under this transformation. What do we notice? Okay, I'm going to draw a little grid. This is so unbelievably important. So 1, 0, and 0, 1. I'm going to plot this point. 1, 0, and 0, 1. Okay, so I'm going to use my transformation matrix. 1, 0, 0, negative 1. This is the transformation. Our image is 1, 0, right, from that, and then 0, 1. Now, this image is also the identity. This happens to be an identity matrix, isn't it? So we know if I multiply the transformation times the identity, we're going to get 1, 0, 0, negative 1. So I'm going to use different colors to represent the different points here. So I'll use blue for this point. So this point, the original 1, 0, is going to still be 1, 0, isn't it? And this 0, 1 is now going to become 0, negative 1. So I'm going to call this blue thing, I'm going to call this A, and I'm going to call this original dot B. So this is B. This is point B. And this later here is going to be B prime. And so this trans transformed to B prime. Okay. So test your conjecture by considering the image of 1, 0, 0, 1 under the transformation represented by the matrix AB. So if I've got A, B, C, D as my transformation, and I'm multiplying it by 1, 0, and 0, 1, we're going to end up with the same thing. A, B, C, D. Okay. So this is our image, which also happens to be identity matrix. Okay. And once again, the result is going to be the same as the transformation when our image happens to be the identity matrix also. Okay. So stretching. Okay. So when we're dealing with stretching, this is our transformation, right? So our transformation is going to, instead of being x comma y, the new location is going to be k times x, and the y value is just going to stay y. And so whenever you have a horizontal stretch, horizontal means I'm going to go from here over to here. Okay, and notice this is x with the prime and the y with the prime. Okay, the British people in the videos were calling that dashed. So prime or dashed, whatever. Okay, the vertical stretch, it's going to move up. Notice here we have 0, 1, so the x value will stay the same, and 0, k, the y value is going to be k times y. That's our new y value, and it's going to move from here that direction. Okay, so here, I'm just going to talk through the stretching. So our value is up here, so we know that it's going to be a horizontal stretch and by a factor of a half. Here, because the value is there, it's going to be a vertical stretch by a factor of 2. Here, because the value is there, horizontal stretch by a factor of 3. Here, because the value is there, vertical stretch by a factor of 1/4. Okay, consider the horizontal stretch by a scale factor of 5/2. Write down the transformation matrix. So the transformation matrix is going to be 5/2 right in there. Okay, hence find the image of 3, 4 under this transformation. So the point 3, 4 is going to be stretched to a new location, so I'm going to put this here. So I can multiply this row times this column. So 5/2 times 3 plus 0 times 4. Okay, and then this spot here is going to be 0 times 3 plus 1 times 4. Okay, when I multiply this row times this column. And then notice how the 4 stays the same, and then we have 5/2 times 3. Okay, find the inverse matrix. So what we learned in our previous lesson is that these switch places and these become negative, but as negative 0 is still 0. So okay, actually they didn't change places, did they? So what happens, so the inverse matrix to go from that back to its original place, I'm going to have to, if I've made it larger by 5/2, if I want to get back to the original space, I'm going to have to make it smaller. So I'm going to have to multiply it by 2/5 to get it back to its original spot. Okay. In the same way, a vertical stretch, we're going to have the 3/4 in this location, and then multiply that times our image of -1, 2, and after we do our matrix multiplication, we end up with our new coordinate, which is -1, 3. 3/2. Okay, and then the inverse matrix that we need to get it back to its location is going to be, we're going to have a 4/3 here. Okay, now to the tricky stuff. I guess it's not tricky yet. Enlargement. We'll do the rotation in a separate video. Okay. So, enlargement. So, consider the points 1, 0, and 0, 1. Suggests that we want an enlargement by a scale factor of 2. Okay. So, if we want an enlargement by a scale factor of 2, we're going to use the matrix 2, 0, 0, 2. Okay. Now, if I do matrix multiplication, I'm going to multiply this row times this column. Oh, we've got our original points here. We've got 1, 1, 2, 2, and 3, 1. Okay. So so this is my image. This is my transformation. So 2 times 1 gives me 2. 0 times 1 gives me 0. And if I go through the process here, I end up with 2, 4, 6, 2, 4, 2. So this is A, this is B, this is C. So our new location is going to be A prime, B prime, and C prime. And so if I plot 2, 2, I'm here for A prime, 4, 4, I'm here for C prime, and 6, 2 here for B prime. Okay. Now, they said, so if I'm going to enlarge, okay. Okay, so 6 here says, okay, let's think about a matrix that represents a 90-degree clockwise rotation. If I've got a 90 degrees clockwise rotation, then I made up this example here. If we've got 0, 1, 1, 0, and I've got this original point, which is right here. What did we do here? Okay. If I'm going to have a parallel stretch, so what we're going to be using is, so these transformations we're going to use these if we are going to stretch parallel to the x-axis. We're going to be using this, and then the value here is for our stretching. For vertical stretch, we're going to have our k value there, and enlargement, we're going to have the same value here. Okay, and in my next video, we're going to talk about rotation.